All right, here we go. Here we go. Check, check, 1, 2. Check on the mic. All right. Hello world, it's Siraj. Welcome to week 4 live stream. Today we're going to start off with a Q&A and then we're going to get right into the code for this week, which is some homework help. I want to help you guys with the homework, and so this week's live Q&A coding project will involve homework-like material, basically transfer learning. We're going to focus on transfer learning. We're going to start this. We're going to do a Q&A. I'm watching the comments. I'm looking at any questions that you guys have. I'm going to answer them. And while I wait for some questions, let me also say that I spent this weekend just by myself in a cabin in Portland just to think about this future that we're heading towards. And I came to some interesting conclusions. I read the simulation hypothesis, this great book by this MIT computer scientist. And I think that we are absolutely about to build some incredible technology in the coming years. I thought it was going to be fast before, but now it's like I'm realizing just how fast it's going to be. All of this change is going to be. For example, this whole course that we're in right now. Think about all the components of this course. You've got me, an avatar who is live streaming knowledge to you. You've got text, video content, image content. So you have different data types for content. You have assignments. You get grades back on those assignments. You get a certificate. All of this can be generated by AI. All of it can be generated by generative models. And not only can it be generated, it can be personalized to you. You could choose the avatar you want to teach to you and, name some random celebrity, Johnny Depp. And then you can have a deepfake video conditioned on the data of whatever the domain knowledge you're trying to learn is, and have it speak to you. It could follow certain learning objectives that we can predefine. It could use intent recognition to know what to teach, what to say, what to test you on after it generates some content. So that's going to change education entirely. I was also reading Exponential Organizations this weekend, and I realized that the most successful organizations these days are not the ones that will build on top of existing infrastructure. They're gonna be the ones who, or sorry, they're not gonna be the ones who rebuild the existing infrastructure from scratch. They're gonna be the ones who build on top of the existing infrastructure. And they're going to be very light, thin teams of people. For example, Kodak. Kodak had 200,000 people, okay? This is a photo creation and sharing company. Instagram had 20 people. 20, 200,000. Kodak went bankrupt. Instagram was bought for over $1 billion. This is just one example of the new type of corporation that's emerging because of automation technology. You can lower costs drastically. 10x, more than 10x. And you can provide services that are 10x more efficient. So we have to think about how AI is going to be integrated into these applications. Jim has this great point of it's going to be difficult to compete with big tech. It will be difficult to compete on the products that they have already built. For example, it will be difficult to compete with mapping software because Google has definitely a great product in that category. But it won't be difficult to compete in the industries that they are not attempting. Agriculture, finance, education, healthcare. Okay, here's the thing about healthcare. Welcome to week 4. This is healthcare. There's some efforts in healthcare, but healthcare is just such a massive space for disruption that no corporation is going to they can't have a monopoly on healthcare. Let me now answer some questions here, now that I've said my spiel. Who will be the next winners in the age of implementation? Huh. Oh, okay, so for the age of implementation, it's going to be people all over the world. It's going to be more distributed than ever before. It's not going to be some kind of nation state has a monopoly on innovation in this field. It's going to be everybody everywhere. The tools for innovation are being democratized to people all over the world. Two more questions. Oh, here's a good one. Can you give me some ideas, projects, thoughts about AI in robotics? I want to start a startup or do amazing projects for a better job in the field of robotics. Sure. So, a couple of things. First of all, when you're thinking about anything robotics related, you want to first start thinking about, well, first the application. What are you going to do, right? That's the first thing. Second of all, what is the fastest method to prototype? What is the most simple prototype you could make? And when we think about that, what comes to mind for me is either the Arduino or the Raspberry Pi. You have to start thinking about microcontrollers that you want to use here. And then based on those microcontrollers, you want to add in some motors, some servo motors, and some 3D printed parts. And you could build anything within a week, really. Any kind of simple prototype. Can you recommend any data science boot camps? I don't believe in boot camps. Boot camps are just not, they're not useful. I think that these data science boot camps are, I mean, some of them could be useful. I think Galvanize is a good example of one, but for me, I like full autonomy in the way that I learn. Like I learn the best whenever I have the most motivation and when I define my own learning curriculum. Like I like to be in control of my learning destiny and what topics I'm going to learn next. And so for me, that's just never been the case. Okay, one more question, and then I'm going to get started here. Is it a good idea to participate in Kaggle to build a reputation in AI ML to apply for jobs? Yes, it is a good idea to. Yeah, Kaggle's a great money-making resource, and I'd love to see us have a Kaggle team, but that's going to be later on. Okay, one more question. I love watching your live streams. Thank you. Are you going to do some after the course? You know what? I don't think so. I really don't think so. I do these live streams for you guys. I don't know if I want to do them publicly. What job titles correspond to the curriculum? Great question. So first of all, machine learning engineer, data scientist, um, anything related to data. But then there's also anything related to database engineering that has to do with uh, machine learning, BigQuery, any of those technologies. All right, so, and then of course software engineer, like generic software engineer, all right? All right, here we go. Let's get started with this live stream. All right, so what we're gonna do is we're gonna do some transfer learning. And this is an example from the homework that I basically just wanna go over right now. So we're gonna do this in the browser. You can pull up Colab, you can do this with me, and we're gonna get started, all right? Let's get started. Hold on, stop that. Okay. Let me just make sure everything is here. I'm going to answer questions periodically, but right now I'm going to just start building because that is what's important. Transfer learning. Okay, all of this code I'm going to do right here in the browser, the full pipeline right here, so you can do it too. And also, I just have to answer this one question by Joanne. My barrier is how to make the code live on the website. How will I be shown that part? Yes, you will be shown that part. I'm going to show you how to do that. Basically, the idea is that from a single command on command line, you'll be able to push it to Heroku or Google Cloud or AWS. But basically, it's a command line integration. All right. So, okay, we're going to perform some transfer learning. And basically, the idea here is that whenever you're building any kind of classifier, guys, I think that classifiers are the lowest hanging fruit in machine learning. Classifiers are the way to really make some money, because you have these massive classifiers out there that are able to you can just pre-train, retrain them for whatever use case you want, and immediately you have this custom machine that you can paywall. You can essentially paywall, and you can build a service around. So knowing how to do transfer learning is a crucial skill to be able to make money with machine learning. Any kind of vision work you want to do these days, it's going to involve a classifier for sure. All right, so let's start off with the imports. So OS is going to be for reading from the file. Math is going to be from math is going to be for any kind of data pre-processing. And then we have NumPy. And then we have JSON. So JSON is going to be for reading data, because we have to think about all the different ways that we're going to have data be used in this app. So we have NumPy for the data pre-processing. Matplotlib is going to allow us to visualize the data. And then we have everybody's, let me make this a lot bigger, by the way. Let me make this a lot, put myself in this corner right here too. All right, there we go. Good stuff. No thanks. All right, we're all zoomed in. So everybody's favorite machine learning library, TensorFlow. And then we have TensorFlow for machine learning. And okay, I also want to say that we're going to do eager execution. So I really want to talk about this, by the way. Eager execution is a type of machine learning that we need to understand. So there's two types of machine learning. We have define by run and define and run. So let me just show you what I mean here. Define by run and define and run. So define by run is basically how models are built in PyTorch. In short, they're the good way to build models, because they're faster, they're dynamic, they're more resilient, they're easier to train, they're faster to train. Basically, the idea is that as this computation graph is built, this neural network, whatever machine learning model, all of the computations are computed. All of the math operations are computed in real time. Whereas with define and run, this is the older way of doing things. You would define the model's operations, and then at compile time, that's when it would perform all of the, that's when it would actually perform the computations. And this is slower. So right now in TensorFlow, we have to kind of manually say that we want to have eager execution happen, because for transfer learning in particular, it's a very important skill. Now there's one more thing I want to talk about here before we get started, and that's auto-tune. So this little auto-tune command is useful because it makes training faster. If you look in the TensorFlow docs, you'll find that optimizing performance involves not just making the model training as fast as possible, but making the data pipeline process as fast as possible. Because when you think about the training process, you have data preparation and then training, and then data preparation and then training, because data is fed in batches to the network, right? There's batch after batch after batch. So we want to make sure that batch process is as fast as possible. And so that's why we do transfer. That's why we want to use this auto-tune method, because it does that very fast for us. All right, so that's for imports. Now let's talk about the configuration. So how do we want to configure this? So an easy way to get some files into this is to let's see, we can use the GCS pattern here. So let me explain what I mean by GCS. So GCS pattern is a way for us to track where our file is. So it's right now, it's already on Google Cloud, so that's good for us. Let me also, while we're at it, show you how to upload a file to Colab as well, because that's just a useful skill for all of us to have. 192.68, 192.2.tf record. So by the way, this is a TF record. So TF record is a type of file that is formatted for TensorFlow. So this is a data set of images. Now, it could be anything. It could be a CSV, it could be a, whatever. But we've chosen the TF record example, and there's so much documentation on TF record. But basically, the idea is that any kind of image data set that we want, if we want to feed it very easily into TensorFlow, we convert it to a TF record. That's the basic idea there. And so this file is already there on Google Cloud, and this allows us to be able to do what we have to do with TensorFlow. So, by the way, this is TensorFlow version 2. All right, so now let's get our image size. So each image is going to be 192 by 192 pixels. We need to know that beforehand. Now, then we have our batch size. So remember I said how we have data, it's fed to the model. Data, it's fed to the model. How much data at a time is going to be fed? We'll say 64 images. Now we can tune this accordingly. Now, every training loop inside of that loop is called an epoch, like a mini batch loop. We'll have 10 of those. Now, we're also going to split our training and testing data right down, not down the middle, but via an 81% split. So 19% versus 81. So we'll say 0.19. All right. And now we have our classes. So what are the 5 classes? This is a multi-class classification problem. We have daisy, that's a type of flower. What else do we have? We have dandelion. We have roses. We have sunflowers. And we have tulips. So those are our 5 classes that we're going to predict from this file. We also want to do a little bit of visualization here, just because it'll be helpful for us as we perform our machine learning. What type of visualization do we want to do? Well, we know what our file names are going to be, gfile. Why not 80? I mean, good question. Let's do 80. I mean, there's no reason to do, there's no reason to do 81. You're right. It's nice to have even numbers. I agree with you, Maximiliano. So we have our gfile. Okay, so we create a file using that GS pattern. And now we split the file into training and testing sets. So it's going to be an integer of length, however long the file name is. And then we have our training file names that we'll capture. File name split. I will share the link right after this. There we go. I will share the link right after this. Okay. Split. We want to split this thing, and then we're good. Like, this is really just a key little bit here, like a few more lines here. Let me explain this. Okay, so some people are getting lost. This guy wants me to copy paste the GSCS pattern line. Sure. Let me paste that. Let me just paste this in for you guys. Give me a sec. Hold on. Okay, hold on. I'm gonna go back and explain this. Let me just give me a second here. All right, there's a GCS line. I just need to write 2 more lines of code. Training file names, we have our validation file names. See, Zhan Wei is on it. He's just blowing through tutorials. Zhan, that's what you got to do. You just, whatever it is, just zzz, just right through your skull. All right, hold on. Split. It's hard to both explain and type at the same time. I understand, but look. Okay. 2 more steps. 2 more lines, and then I'll explain this. Validation steps. And steps per epoch. Equals I don't know. How many steps do we even want here? I don't know. 30 steps? I don't know. Let's say 30. Let's just see if this compiles. This is not going to compile. Oh, it compiled. No, it didn't compile. TF is not defined. I just defined it right up here. Oh, really? Okay, so there we go. Okay, so what are we doing here? So, all right, so here's what happened. We have this file data set. It is in the cloud. Here it is. It has been pre-uploaded. Now, if we want to upload our own file, we just go to Files, check this out, Upload, and then we just upload our file like that. And then we call it right here. Okay, but we didn't upload our own file. We found one that's already there. Then we have defined a bunch of configuration parameters for our network. What's the image size? What's the batch size? How many epochs? How many classes? All right. And then we define a bunch of configuration files for the network. Like as we train this, we're not going to just train on the data set raw. We're splitting the data into some training set and a testing set. When we finish it on the training set, we can test it on the testing set and see how good the predictions are. Now, all of this data has labels as well, right? So that's it for our configuration. Now I have so many read data functions right here, right? I have about 114 lines, not that much, but just some lines here that I'm gonna paste in, and we're gonna talk about it. Let me just see if it works as well. I'm gonna give you this whole collab, all right? Don't worry. See, of course there's gonna be a problem. Hold on. Hold on. We want to figure this out. The classes are just labels. We have some great questions in here. Someone asked, what is transfer learning? All right. Okay. Where were we? What is the problem here? 112 is the problem? Let me just make this. All right, great. Let me just answer some questions for a second. Some people have some questions here. The classes are just labels? Yes, the classes are the labels themselves. Classes, labels, sometimes we call them target variables. This is one of those things in machine learning where we have a lot of words for the for the same concept, and that can get confusing. What else do we have here? We have transfer learning. So transfer learning is basically the idea of taking a pre-existing model, a pre-existing machine learning model, and then retraining it. So taking that model, it's trained on some data set, and retraining it on a different data set. And by doing so, you are leveraging the abilities of the pre-trained network, so you don't have to train it a lot. So you already have this pre-trained network. It's really powerful already. It's right out of the box. It kind of works. You just have to do a little bit of work to make it perfect for your use case. I'm a student. Should I try to start a startup or focus on enhancing my skills and programming? You should focus on enhancing your skills and programming for sure. For sure. Is that even a question? For sure. Hold on. Hold on. All right. So, and then what other questions? A lot happening here. Edit. Make sure it's all there. All right, guys, we're gonna finish up this code now. Let me just make sure I've got all the little missing pieces here. All right, let me also just change this. You know what? It's just, all right, we're just gonna do this. I'm gonna paste this into here. Hold on. Okay, here we go. We're about to switch things up right now. All right. Okay, we're gonna connect to this. All right, I just pulled up this notebook. I'm gonna share it right after this is done. It is hard to answer questions and do this at the same time. It's okay though. All right, so we've had TensorFlow. This is exactly what we did before. This, we don't have to worry about this collab off. Not even necessary. Let's just delete that. Delete, bye, get out of the way, confusing. Configuration, exactly what we did before. These are those read functions. Okay, these are just all data reading functions. Display 1 flower, display 9 flowers, display 9 flowers with their predictions, display the training curves. So that's just matplotlib. Reading the images and the labels from the data. Remember, in the data, it's separated by the image and then the label, or the class, whatever you want to call it. And then once we have those, we return them. These are data loading functions, and then we can display those images like this. Come on, Google Colab. You better display my 9 images. Good. So this is just displaying those images. It's TF2, by the way. This is just displaying those images and the labels. Sunflowers, daisies. Another data read function. Now, here's the important part right here. This is just like 6 lines of code, but this is like what matters. In this model, we are saying, let me take this existing model called MobileNet v2, include the top equals false. What does include top false mean? It means that this is MobileNet. MobileNet is a convolutional network with all of these layers to it. Okay, so all of these rows are different layers of this architecture. And they all have a different filter shape and an input size for the amount of data that goes into that layer. Now, for this input type, what do we do? What we do is we say, let's just take off this last layer, this softmax layer, and then instead, I'm sorry, and instead, let's create our own. So what we do is we say we're going to freeze those weights. So trainable equals false means that we freeze the bottom weights. So we're not going to retrain those weights. We're going to add in our own set of weights at the end. We're going to basically tack it on top of the model. And we're going to retrain it on our data set. So let me just say that one more time. MobileNet was trained on cats, dogs, cars, people, planes, everything. It's pre-trained. It took 2 weeks or something to train. We take MobileNet. It's already a great general classifier. We cut off the top of it. We add in a little bit of our own matrix operations. What I mean is we add this flattened layer and a dense layer. The reason we're doing this is because the dense layer is what is going to output probability values for class prediction. But it expects a flat vector, a one-dimensional vector. So it's going to be n-dimensional, right, when it gets to dense. So first we have to flatten it, and then we give it to dense. So that's why we have these two different layers. Then, once we built that, we put it on top of the model, right, that we cut off the head, and we say, here's the model summary. So that's us adding our own special layer to a pre-trained network. It's going to download MobileNet, and then we can fit it on our specific data set. And what that does is it trains a model directly on our own data, but it leverages all of the power that it has that it trained from another data source. And when we do that, we can print out the, right now it's training. It's going to take about 3 minutes to train, which is not bad. And then we'll make some predictions, and it's going to say, oh, these are all the predictions. False prediction, true prediction, right? And once we have this model, we want to put it on either a web app or a mobile app, and we want to put a paywall around it. Now, classifiers are the lowest hanging fruit in machine learning, in making money with machine learning. I believe that. Just think about any industry and think about how vision is being used by humans to complete some task, and how a human is being paid to use their vision to classify something. You can automate that process, okay? So let me answer some questions, okay? What is the base MobileNet architecture? So MobileNet architecture is a series of convolutional operations. I think it's about 30 different blocks, 30 or 32 convolutional blocks just chained together. How do we apply ML algorithms to small and medium businesses? Great suggestions. So, really interesting use case. So what are things that all small to medium businesses need? They need a service that's going to help them make actionable insights using their data. So I think for small and medium businesses, the lowest hanging fruit is doing a data consultancy service. Like saying, give us your data, we'll tell you how to make better marketing decisions, better sales decisions, better design decisions, how to increase customer retention, how to reduce churn. Brian, the answer is yes. You can send it by CodeLab. All right, let me start from the top, go down. How would you go about using unsupervised learning with an illustrated example? I'm guessing we have to build something customized. For unsupervised learning, the easiest way to start is clustering. The easiest algorithm is k-means, and the easiest library is scikit-learn. How are you going to separate the groups for midterms? As you mentioned, you'll also be referring us to some consultation work. Will it be paid work? If yes, in how many weeks? So for midterms, that's week 5. That's next week, so it's coming up. Basically, I'm going to ask students to find a partner for the midterm, and then those who can't find a partner, I will group them together. I'll send out a Google form that says how many people do you want to be in your group, what's your group idea, and then I'll match them together. But ideally, they'll find their own groups in Discord. And then in terms of your second question, referring us to some consultation work, yes, that's at the end of the week. That's at the end of the course. But why make male models? Good question. Female, androgynous models. What's the difference between validation and testing data? So testing data is for I mean, they both achieve the same general purpose of ensuring that your classifier is robust. But validation data is more like to prevent overfitting, whereas testing data is to is to ensure that the model is going to work on novel use cases. I agree, Maximiliano, on your suggestion. I agree. Um, right. So, guys, we need to start. I want you guys to already start be like thinking about your midterm like right now. What is that app that you're just itching to make? There's got to be at least one idea that you just it excites you. You know, something that you just if it existed it would be so cool that you yourself could use. You know, for me, it's automating the whole education process. I'd love to create AI that helps me generate valuable content, personalized content for students. I'd love to use AI that helps me grade. I'd love to use AI that helps me support students, chatbots. Like, imagine you could automate the entire university pipeline. Like, it's insane how much you can disrupt education and every industry with this technology. It's just about thinking about these pre-trained models, and then the code for web apps and mobile apps is kind of just the glue that just sticks it together. But these pre-trained models running inference one on top of each other, that's the real value of an app. But the glue that makes it all stick together and makes it pretty for a user to use is Flask, is Flutter, is Django, is Node.js, these web and mobile frameworks. Veloshan, you won't need to use Flutter for the midterm. We'll be talking about Flutter for the first time starting next week, and it will be nice to use Flutter for the midterm. All right, one more question. How do we get images to train medical ML models? You know, getting medical images is one of those hard things because it is sensitive data. But luckily for us, the NIH made the largest set of medical imaging data ever available to the public. 32,000 images. Thank you, National Institute of Health. 32,000 images right here. That's what I'm talking about. That's what we need. All right, one more question. Do I really need a co-founder? You don't need a co-founder. No, it's just nice to have. You know, I've thought many times about having a co-founder for what I do, but I like working alone. So, you know, this co-founder's not for me. Thank you, Saman, for that insightful comment. Yes, Jim. NumPy, Pandas, Scikit-learn. You can't go wrong with those three. All right. Startup pipeline. Yes, it's coming. Thank you, Angel. We're gonna revolutionize everything. Gopal. Yes, I will do that. All right. Thanks, guys, for showing up for this live stream. It was actually I have the Google interview. I have a video coming out on that tonight. So this Google interview question person is coming tonight. All right. Thank you guys for being here. I look forward to seeing your homework. This week it's all about healthcare, so we really want to dive into all the possibilities for healthcare. I really think this is one of the lowest hanging fruits. I know it's too early to start talking about BioBERT, which is a language model that can give you automatic diagnoses. But I just want to mention BioBERT as well. Image classifiers are still the way to go with medical data, but there's a lot that can be done here. I hope to see your homework, guys, and I will see you in my 2 office hours this week in Discord since I missed last week, Thursday and Friday. All right. Thank you guys for showing up. I love you, and I'll talk to you later this week. Bye.